Hello, welcome to our introduction to LavaMoat. Let's start with a simple question. Would you take a string I gave you and run it in your application's process? Okay, what if I offered to pack it in a tar.gz file for you? Would that help? I mean, that's what NPM packages are, and they're glorious, and we're using them all the time. But they're also unsanitized input from the internet that you run. Wouldn't it be great to fearlessly consume NPM packages, even if some of them could be malicious? Are we considering that? Well, I know we are. Let's look at this story. Meet Dave, a software developer. He's working on a JavaScript project and decides to install some dependencies, like we all do. And now, here's a hacker lurking. The hacker happens to control one of these dependencies. Let's not get into the details of how, because we don't have enough time for that. So one of those deeply nested dependencies somewhere is malicious, okay? So would Dave run it? Dave thinks he wouldn't. Well, how can you run code from a dependency that you're not even aware of? Well, the problem is there's a lot of ways to do that. So a lifecycle script is being run every time you install your dependencies. And a post-install script inside of one of your dependencies could do anything to the entirety of your operating system as your current user. And that's what hackers often use. So what do we do about that? Dave has a great idea. Let's spin up a Docker container in CI, run the installation, take node modules, put them somewhere safe, and destroy the entire container. So whatever the hacker decides to do with the operating system of the container, or however they decide to affect the rest of the build process, that would be impossible. And we still have the node modules we wanted out of the installation process. Well, this can be worked around. Imagine the hacker delivering their package with a post-install script that ends up finding the TypeScript installed alongside and delivering a payload directly into the TypeScript compiler inside of your node modules. And that change to the TypeScript compiler makes the compiler insert malicious code into your application whenever it compiles it. Would you look at the result of TypeScript compilation? Probably not. So what do we do about it? Well, Dave decides to ignore scripts. And this is a good idea. It's better to not run any of those scripts if they can be dangerous. The problem is they are there for a reason. So some of the packages now are not working. Dave decides to run npm rebuild bcrypt because the bcrypt package requires compilation. What can a hacker do now? Well, it happens to be possible to spoof the package name. So the evil package that our hacker has delivered to Dave's dependencies can now have a dependency called bcrypt. And that dependency is a bundled dependency, which means it's delivered in the same tarball as the evil package. And that dependency now has a post-install script. And guess what happens when you do npm rebuild bcrypt? Everything called bcrypt in your dependencies is going to get triggered. We're back to square one. Oh no, what's Dave going to do now? Well, Dave is going to take LavaMoat and use it. Let's look at the first most basic tool in the LavaMoat tool belt. It's called allow scripts. You set it up and it defines the ignore scripts in a way that's applicable for your package manager. And then you run allow scripts auto, And it's going to create an entry in your package.json that contains a list of things, a list of packages that want to run lifecycle scripts, and you get to decide which ones are going to do that. Also noteworthy, post-install always fail is another tool. That's a second layer of protection. So it throws an error whenever its post-install script runs. Sorry, pre-install script. So it's even earlier. And that means if you happen to accidentally delete your npmrc or undo the configuration in any way, this is going to error out as early as possible to stop you from potentially running malicious post-install scripts, right? Now, for those scripts to actually run, after the installation, you need to call allow scripts without any arguments, and that's going to run everything from your allow list. And for convenience, you can put it in an additional script, so you can do npm run safe install, for example. And at this point, we're happy with how safe installing packages is. Just make sure you don't install packages from untrusted sources, and you should be fine. Until you decide to run any JavaScript. So now let's look at a more serious case of a hack. Imagine the hacker goes and contacts the maintainer of a package that you're actually using, some software that you're running in your CI, for example, and convinces them, which isn't that hard, to participate in maintenance of the package. The next step is obviously to put some malicious code in there. So imagine this code stealing your GitHub token from GitHub Actions and sending that over HTTPS to the hacker's own server. It's not fun. Would you read your node modules to find these? That's debatable. Some companies do that, but it's really time consuming. But even if you wanted to do that, what about some obfuscation? You can still see GitHub token in here, so maybe let's keep going. This is even more obfuscated, and there's no way to find out what the strings were. And this obfuscation is multi-layered and hardly possible to deobfuscate. But that's not going to prevent LavaMoat from protecting you at runtime. So the great thing about JavaScript obfuscation is that it needs to recover the actual runnable code for the runtime. And at runtime, it needs to access powerful APIs to be able to do anything. And that's where LavaMoat comes in with the policy. So you have two steps. You have a step where you use LavaMoat to generate a policy, and then you call your application, in this case, the build script, with LavaMoat, and it's going to apply that policy. So let's look at a small section of the policy file. It's that ESLint plugin that the hacker is helping maintain, and it suddenly depends on an evil package, and that evil package before obfuscation would look like this. So we have HTTPS request and process env in the policy. You can decide to override the policy and say that HTTPS and process should not be accessible for evil package. But more importantly, if the evil package is obfuscated, static analysis that generates the policy, the initial policy that you then evaluate, is not going to detect that. And by default, none of these powerful APIs are going to be available. Which means when you run your build, one of these errors is going to happen depending on which item was attempted first. So it's either refusal of getting HTTPS imported into evil package, or a type error where reading env from process fails because process is undefined. And notice that process is accessible elsewhere. So other packages that you allow are going to use process just fine. But for this specific package, if we don't declare in a policy that it's supposed to access process, it's not going to have access to process. The process global is going to be undefined. Well, how is that even possible? Okay, let's take a tiny peek what's inside LavaMoat to explain this. So what LavaMoat is using is called hardened JavaScript. Each package is put in its own compartment with separate globals on top of hardened JavaScript. Let's look at the ingredients. Hardened JavaScript delivers two main items. One of them is compartment implementation. Compartment is a box in which you can put some code and run it in isolation within the same process, within the same thread, but it's isolated from the scope of everything around it. That means you can control what object is going to be the global object for that code. And LavaMoat puts every package you use in a separate compartment. Another thing about hardened JavaScript is it provides lockdown. LavaMoat calls lockdown to prepare the JavaScript environment and to prevent the possibility of prototype pollution on the items that are built into the language. They are called intrinsics. So lockdown is protecting intrinsics from being modified, eliminating a whole class of attacks that could be used to escape from the compartment or to run prototype pollution attacks on your application. Side note, JavaScript design is actually good for security. It just so happens that ECMA and the TC39 group specifically is defining the language itself, but there's no powerful APIs in the language itself. All network access, all I/O, and everything like that is being defined by someone else. And that someone else was W3C and then Node Core. And now for multiple runtimes, it's WinterCG. But these are separate organizations. So at Conway's law that says the software that's being shipped is going to represent the communication structure of the organization that produces it. This gives us very good separation between the language itself and the powerful APIs. So any power is only reachable through scope or through importing things into your scope. And compartment controls both of these things. And then hardened JavaScript comes in to prevent any leakage of resources across scopes. And we're ready to secure your packages from each other and to secure your application from those packages. Okay, that was a lot. So let's give it a brief summary. Your installation time is protected with allow scripts. Then your runtime is protected with LavaMoat and policy. And then all of that is possible thanks to hardened JavaScript with SES. LavaMoat is protecting the installation, build, and runtime in the browser of MetaMask with up to 30 million users. And it's been doing that for years now. By the way, since we're mentioning the browser, we have a Webpack plugin and a tool for Browserify. So you can also create your bundle with all the compartments built into the bundle. And that's LavaMoat. Protect your JavaScript. LavaMoat is free and open source and will remain free forever.